All right, fellas. We are getting into investigation two. This is on the Pythagorean theorem. So this is my first time doing this through Zoom. So hopefully this works out well. But let's get into it. So many of you guys have probably heard of the Pythagorean theorem. Pretty sure you guys did some of this last year. Real quick, we'll review. So many of you likely have seen the Pythagorean theorem stated as a squared plus b squared equals c squared, which is great. However, we're going to break it down a little bit further and say that really what we're talking about here is a triangle. If I have a triangle that is a right triangle, then in every right triangle, I have a side that is a leg, another side that is a leg, and a side that is called the hypotenuse. So it's really important that we know these pieces and which is which. Okay. So the legs, there's always two, and the legs are always the sides that make up the right angle. Right? So the legs will always connect to form the right angle, and the hypotenuse is always across from the right angle. So if we talk about the flashlight that we've talked about before, that's shining, this is the angle, this is the amount of light that shines in our flashlight tag game. So that is known as the hypotenuse when it is across from the right angle. Okay, so this is also the longest side in every right triangle. Sorry, sloppy. Okay, so if we go back to this formula, what we really should say for the Pythagorean theorem is that it is leg squared plus leg squared that equals the hypotenuse squared. Okay, so this is true. This is like the shorthand version, right? This is the abbreviated version of this formula in blue, right? Where A and B are always my legs and C is my hypotenuse. This can get a little confusing, obviously, if we have a problem where an unknown side is labeled as A and it's on the hypotenuse, right? But as long as we keep this formula straight in our heads, then we should be able to solve for any unknown side of a right triangle if we've been given two. Okay, so let's take a look, right? Really, what this means is Pythagoras, right, found that if you have a right triangle, we'll go pink here, that if you have a right triangle, right, and really if, let's say we have two squares instead of a right triangle, okay, and these two squares sit to form here, right, and we'll say that this square has a side of 3 and this square has a side of 4, that if they form a right angle here, that the distance between here and here, right, that side squared will equal the sum of these squares sides squared, right? So let's see if we can find what this side is, right? So again, we're just going to plug into our formula of leg squared plus leg squared equals hypotenuse squared. So I know my legs are 3 and 4, right? This is a 4 because this is a square. So all of these are 3. So really what we're saying, what Pythagoras is saying is that the area of this square plus the area of this square will always equal the area of this square. All right, so let's plug in our legs. We have a leg of 3. So again, use parentheses to show substitution. Plus a leg of 4. And that's going to equal, substitute this x in for the hypotenuse. That's what we're looking for. That's going to equal the x squared. So now we start to solve, right? 3 squared is 9. 4 squared is 16. And x squared is x squared for now. All right. We can continue. Let's gather some like terms here. 9 and 16 is 25. So we know that x squared equals 25. So I'm going to flip this and say x squared equals 25. But we're trying to find x, right? And so we're going to apply a math trick for morons. To undo squaring something, we're going to square root it. So that's square root of x squared is going to give me x. Good, that's what we want. But I got to apply that to both sides for balance. So on this side, I get the square root of 25, which hopefully we know is 5. So my answer here is 5. And that makes sense, right? This is 9 for the area here. This is 16 for the area here, right? Probably look familiar. And so we know that 9 and 16, these two areas, if we add them together, it's going to equal the area of this square. So that would be 25. So if this is a square with an area of 25, what is its side length? What is the hypotenuse? Well, square root of 25 is 5. So that would be 5. So x equals 5 here. All right. Let's try another. So I'm going to go to a new slide. Let's go with, if we have a right triangle with sides of 12 and 16. I really wish there was a triangle shape in whiteboard here. So here's my right triangle. And I am told that I have sides of 12 and 16. Okay. So then we want to know, what is this side? Well, let's call this side Z. We want to find Z, right? So find Z. So take a moment, maybe pause the video, see if you can do this. Give yourself a chance. All right, welcome back. Hopefully you paused and attempted this one. If not, do it. Remember, we're going to plug into leg squared plus leg squared equals hypotenuse squared. So I know 12 is a leg, 16 is a leg, and Z is a hypotenuse. So let's plug into our formula. So it's going to go 12 squared plus 16 squared equals Z squared. Again, a couple things, right? Maybe get in the habit of making your Z's have this little cross here, this little dash on the Z, or you know, make your 2's have the little loop, right? So you can make the 2 with the little loop. Maybe that'll be a little bit better of a 2. My Z's and 2's look very similar if I don't put that little dash. So one little tip for you. Second, you got to get in the habit of starting to memorize some of these bigger numbers and squares of them, perfect squares. We're going to see a lot more of these now that we're doing these Pythagorean theorem problems. So let's get into it. 12 squared is 144. 16 squared is 256. And Z squared stays Z squared for now. Okay, I gather like terms. 144 and 256 is 400. So I get 400 equals Z squared. So I'll flip that around. Here comes our math trick for morons. Because I got to get Z by itself to undo squaring. Take the square root. And I balance it. So I get Z equals 20. do another. This time we're going to solve for a leg. So we're given the hypotenuse. Here we go. We will go brown. So here's my right triangle. Remember, this only works for right triangles. Okay. I got a right triangle. I'm told that I have an unknown side of A, another side of 24, and another side of 26. So pause it now. See if you can figure this out. This is a tough one for the square roots. We haven't really gotten above 20 yet. Not square roots, but squares. But again, you should know how to find that. So pause it, give yourself a chance. And here we go. So we plug in. Again, I have A as a leg, 24 as a leg, and 26 is my hypotenuse. Always going to be the longest side and the side across from the right angle. So I plug in, I get A is one of my legs, so A squared plus 24 squared equals 26 squared. A squared stays A squared. 24 squared becomes 576. And 26 squared is 676. Okay, so I'm solving for A. So here we go. This just is an extra step in our rules of algebra. So I have squaring and adding. I'm going to undo adding first, right? Based on SADMAP, so I'm going to subtract 576 from both sides. And I get A squared equals 100. I'm going to undo the squaring now by square rooting. Do it to both sides, and I get A equals 10. Okay. All right. So I think that is going to stop our examples. I have a couple other things that I wanted to go over with you. And maybe I'll end with giving you a couple examples, see if you can find out the answers. I'll post the answers at the end. So you're going to see this idea or this concept of Pythagorean triples. Okay, so the book is going to make reference to this a lot. So a Pythagorean triple. All right. So all this is are three whole numbers that can be the side lengths of a right triangle. So not all combinations of whole numbers will work for a right triangle, right? We can see that. So let's see what we mean by that. So there are some combinations that won't work, right? So if I said to you, I had a triangle with a side of 3, another side of 3, and a side of 10, right? Certainly possible, right? But you may be asked, is this a right triangle? Well, I don't know, right? I'm not told. So, but I do know that if it's a right triangle, then the Pythagorean theorem should work, right? So let's test that. So let's say we're going to say does 3 squared plus 3 squared equal 10 squared, right? Because if it's a right triangle, it should. That's the Pythagorean theorem, right? Leg squared plus leg squared equals hypotenuse squared. So here we get 9 plus 9, equals 100. Does 18 equal 100? And the answer is quite obviously no, right? So we'll get our stamp. There we go. No, right? It does not. So this is not a right triangle, right? It's still a triangle. It's just not a right triangle. And therefore, 3, 3, 10 is not a Pythagorean triple. Okay, so you'll start to see that some are quite obvious, or ones that you'll see a lot, right? So let's look at one that is. So maybe let's see if this one is, right? Let's see if a right or a triangle with sides of 3, 4, and 5, is this a Pythagorean triple, right? Meaning, is this a right triangle? Well, if it is, then 3 squared plus 4 squared should equal 5 squared. Back up, which will be 25. So does 9 plus 16 equal 25? And the answer is yes. So this is a right triangle, and 3, 4, 5 is a Pythagorean triple. And this is helpful because that basically means that anytime I have a triangle that has a leg of 3 and another leg of 4, I'm always going to know that the hypotenuse is 5, right? Always, always. So the other cool thing is that multiples of these numbers will also be Pythagorean triples. So if I had a 6, 8, and 10 triangle, that would be a right triangle. If I had a 9, 12, 15, that would be a right triangle. If I had a 12, 16, 20, that would be a right triangle, right? This is just times 2. These are times 3. These are times 4, right? So that means if I had a triangle that was a 15, 20, what is this side? Well, I might recognize that these are multiples of the 3 and 4 sides. 3 times 5 is 15, 4 times 5 is 20. So this is just my 5 side times 5. So that would be 25. I don't even have to do the Pythagorean theorem because I recognized the Pythagorean triple. So you'll get better at that. I know it might be a little confusing right now, but you will get better at identifying these Pythagorean triples and using them to help you solve for unknown sides. So I think that's it for our lesson today. Hopefully this made some sense. I know that we'll obviously go over more in class. Feel free to email me or reach out with any questions. All right, thanks, fellas.